The universe is calling, and it's not just whispering secrets of its origins, it's shouting about its riches. For centuries, humanity has looked to the stars with wonder. Now, we are looking at them with ambition. Asteroid mining, once a concept confined to the pages of science fiction, is rapidly becoming the next great frontier for exploration and industry. These celestial wanderers, remnants from the birth of our solar system, are packed with valuable resources. They contain everything from water, essential for life support and rocket fuel, to platinum group metals that are rare and expensive on Earth. The prospect of tapping into this cosmic treasure chest has ignited a modern-day gold rush, attracting a new breed of pioneers, engineers, investors, and entrepreneurs. This cosmic gold rush is no longer just a distant dream. In fact, the race has already begun, with private companies leading the charge into the void. One of the most talked about ventures is from the California-based startup, Astroforge. In February of 2025, they successfully launched their first spacecraft, a probe named Odin, aboard a SpaceX Falcon 9 rocket. Its mission was ambitious, a 9-month journey to fly past a near-Earth asteroid called 2022 OB5, located millions of kilometers away. The goal was not to mine, but to scan and analyze its composition, a crucial first step in identifying valuable targets for future missions. This represents a monumental shift from government-led exploration to commercially driven prospecting. However, the path to cosmic riches is fraught with peril and uncertainty, as the Odin mission quickly demonstrated. Shortly after its triumphant launch into the dark expanse, ground control began experiencing severe communication problems with the spacecraft. As of today, in September 2025, contact has tragically not been re-established. This setback serves as a stark and humbling reminder of the immense challenges inherent in deep space operations. The cosmos is an unforgiving environment, and even the smallest technical glitch can derail a multi-million-dollar mission. It underscores that while the potential rewards are astronomical, the risks are equally monumental for these early pioneers. Despite the difficulties faced by Astroforge, the industry's momentum remains largely undeterred. The allure of asteroid resources is simply too great to ignore. Another company, Carmen Plus, has already secured $20 million in institutional investment and has a launch booked for February 2027 to test its own asteroid sampling technology. These ventures build upon the foundational work of national space agencies like Japan's JAXA and America's NASA, whose successful sample return missions proved that we can, in fact, touch and retrieve pieces of asteroids. The private sector is now poised to transform that scientific capability into a scalable and potentially profitable commercial enterprise for humanity. Why risk so much for a few space rocks? The answer lies in the almost unimaginable economic potential they hold. Some astrophysicists, myself included, have gone on record to predict that the world's first trillionaire will not make their fortune on Earth, but by mining the resources of near-Earth asteroids. The numbers are simply staggering. The World Economic Forum forecasts that the broader space economy is on track to become a $1.8 trillion industry by the year 2035. Asteroid mining is expected to be a significant driver of that growth, promising a supply of precious metals and other materials that could reshape global markets and power the next wave of technological innovation. Different companies are pursuing distinct business models, reflecting different philosophies about how to best unlock this value. Astroforge, for example, is focused on the high-stakes game of mining platinum group metals and returning them to Earth. These metals, like rhodium and platinum, are critical for everything from catalytic converters in cars to advanced electronics. With a single kilogram of rhodium currently valued at over 141,000 pounds, even a small asteroid rich in these materials could be worth billions. This model aims to directly supplement Earth's dwindling supply of rare resources, potentially lowering costs and enabling new technologies that are currently limited by material scarcity. In contrast, companies like Carmen Plus are adopting what many consider a more practical, near-term strategy. Their focus isn't on bringing resources back to Earth, but on using them in space. This is known as in situ resource utilization, or ISRU. Imagine mining water ice from an asteroid and converting it into hydrogen and oxygen, the two primary components of rocket fuel. This would create cosmic gas stations, allowing spacecraft to refuel in orbit for long-duration missions to Mars and beyond. They also aim to mine clay and other minerals for three-dimensional printing of habitats and tools, building the very infrastructure of a sustainable off-world economy. This model avoids the controversy of disrupting Earth's markets. The feasibility of all these ventures hinges on a critical factor: the cost of getting to space. 15 years ago, launching a single pound of payload into orbit cost around $10,000. Today, thanks to reusable rockets pioneered by companies like SpaceX, that cost has fallen to just a few $1,000s. With the advent of next-generation launch systems like SpaceX's Starship, that price is projected to plummet even further, potentially to just hundreds of dollars per pound. This dramatic reduction in launch costs is the great enabler of the asteroid mining industry. It transforms what was once an economic impossibility into a tangible and increasingly attractive business proposition for investors. The economic promise of asteroid mining is immense, but so are the technical hurdles. Perhaps the greatest challenge is figuring out how to extract resources in a zero-gravity or microgravity environment. On Earth, our mining techniques rely fundamentally on gravity to move rock, separate materials, and manage debris. Those methods are completely useless in space. Engineers will have to invent entirely new technologies for anchoring to a spinning asteroid, drilling or scraping its surface, and collecting the resulting material without it simply floating away. These are complex robotics and physics problems that are currently being tackled in labs and university workshops around the world. This challenge has sparked a wave of innovation, not just in corporate research labs, but in academia as well. Universities are becoming hotbeds for developing the next generation of space mining technology. For instance, Iowa State University's Cardinal Space Mining Club has gained recognition by co-winning the NASA Lunabotics Challenge in 2024. When they didn't qualify for the 2025 event, they took the initiative to organize their own competition, attracting teams from major universities and sponsorships from industrial giants like Caterpillar Incorporated. These events are more than just academic exercises. They are crucial for fostering the talent and testing the prototypes that will one day break ground on an asteroid. Beyond the engineering puzzles, a complex legal and geopolitical landscape awaits. The foundational law of space, the 1967 Outer Space Treaty, declares space as the province of all humankind and prohibits any nation from claiming sovereignty over celestial bodies. However, the treaty is silent on whether private companies can own the resources they extract. This ambiguity has created a legal gray area. While the 1979 Moon Agreement attempted to forbid private ownership of space resources, it was ratified by very few spacefaring nations, leaving the door open for commercial exploitation. This lack of clear international consensus is both a risk and an incentive for the private sector to move quickly. This legal void is forcing the international community to play catch-up. A special committee at the United Nations is scheduled to formally discuss the rules for space resource utilization in 2027, but its findings will not be legally binding. In the meantime, individual nations are creating their own domestic laws to encourage and regulate their companies' activities. This could lead to a future where geopolitical power is determined not by who controls oil reserves on Earth, but by which nations and corporations command the technological capacity to access the resources of the solar system, especially as we venture further from our home planet. One of the most compelling arguments for asteroid mining is its potential to be dramatically better for Earth's environment. Terrestrial mining is an incredibly destructive and carbon-intensive process. It involves moving mountains of Earth, consuming vast amounts of water, and often releasing toxic byproducts into ecosystems. A 2018 study highlighted this disparity with a powerful example. Mining 1 kilogram of platinum on Earth can emit approximately 40,000 kilograms of carbon dioxide. The same study estimated that obtaining that kilogram from an asteroid could generate as little as 150 kilograms of CO2. By shifting the extraction of certain resources off-world, we could significantly reduce the environmental burden on our home planet. This vision of a cleaner Earth, powered by resources from space, is a powerful motivator for the industry. Imagine a future where the manufacturing of our electronics, vehicles, and infrastructure is supported by metals sourced from lifeless rocks floating in the void, rather than from stripping away our own planet's precious and fragile biomes. This would allow us to preserve biodiversity, protect clean water sources, and reduce the carbon footprint of our industrial base. In this sense, reaching for the stars is not about abandoning Earth, but about finding a more sustainable way to live on it, ensuring its health and beauty for generations to come. However, this promising future is not without its own environmental risks, which must be addressed proactively. A major concern is the potential creation of new space debris. Mining operations will inevitably produce dust, rock fragments, and other tailings. In a microgravity environment, this debris could form a hazardous cloud around the asteroid, posing a threat to other spacecraft. Worse, if not managed correctly, some of this debris could have its orbit altered and eventually fall to Earth, creating a new kind of man-made meteorite threat. Developing clean and contained mining processes will be just as important as developing the extraction technology itself. Ultimately, the pursuit of asteroid mining forces us to confront fundamental questions about our role as stewards, both of our planet and of the cosmic environment. Will we export our historically messy and exploitative industrial habits into the solar system, cluttering orbits with debris and racing for resources without a second thought? Or can we approach this new frontier with more wisdom and foresight? The challenge is to build an off-world economy that is not only profitable, but also sustainable. By learning from our mistakes on Earth, we have the opportunity to make asteroid mining a force for good, one that powers human progress while helping to preserve the one home we have.